All right, today you are going to learn a totally new type of factoring. A difference of perfect cubes and a sum of perfect cubes are polynomials that can be factored. Totally new, you've never seen it before. So, once again, we're going to take a step back. We're going to remember that we have 4 steps that we learned in Algebra 1 to factor. And we're going to have our 5th one now, perfect cubes, sum or difference. Both can be factored. So let's go back to this one. A difference of 2 perfect squares. X squared minus 16 is a difference of 2 perfect squares. I keep saying that over and over again because you won't believe how many people don't get difference, subtraction sign, perfect squares. X squared is a perfect squared, 16 is a perfect squared. All right, we know that when we factor that factors down into x minus 4 and x plus 4. And you're like, hey, Mrs. Trulin, whoops. Why are you writing it like that? Well, if you remember from Algebra 1, that was another way to multiply binomials together, right? We know x squared minus 16 is x minus 4 times x plus 4. We can factor that till, as they say, the cows come home. But I want to show you something here. If you were to multiply these things together, they should get you back to x squared minus 16. Okay, x times x is x squared. X times 4 is 4x. Negative 4 times x is negative 4x. Negative 4 times 4 is negative 16. I know you did this in Algebra 1. It was part of the curriculum. I taught Algebra 1. I know it was there. So if you're going, I never saw that, lies, you did. So what happens here now is you look and you see that, oh, okay, x squared has nobody to combine with. 4x and negative 4x cancel each other out. And negative 16 has nobody to combine with. So x minus 4 times x plus 4 is x squared minus 16. Now, we cannot factor an addition of 2 perfect squares. Every year I get kids that say, yeah, you can. It would be x plus 4 and x plus 4. Well, if you multiply that out, you get x squared, 4x, 4x, and 16. And if you notice, x squared, the 4x's don't cancel out. In fact, you get 8x. And then you're left with a plus 16. So there's no cancellation there. So that's why you cannot factor a sum of 2 perfect squares. But you can factor a perfect sum of cubes or a difference of perfect cubes. All right, so if you notice, my box is set up a little different. I'm going to prove to you why this little shortcut that I'm going to teach you how to memorize works. So as we started up here with a difference of 2 perfect squares, we started off by taking the square root of each term. Well, I'm going to do the same thing with my perfect cubes. I'm going to take the square root of each term. Well, the cube root of x cubed is x. And the cube root of minus 1,000 is minus 10. So that's a binomial, and that's why it goes on the left side of my box here, because that has 2 rows. So as you can see, it's going to get multiplied by a trinomial. So I'm going to go backwards. You see how this was x squared in this box because that was x squared there? Well, this should be x cubed because I'm trying to get this x cubed here. So x times what gets me x cubed? X squared. X squared times negative 10 is negative 10x squared. Awesome. But if you look here, I don't have any squareds in my original. So therefore, all my squareds have to cancel out. Well, the only way to cancel out a negative 10x squared is to have a positive 10x squared. There. They're going to cancel each other out. So what did I multiply by to get that positive 10x squared? I must have multiplied by a positive 10x. Positive 10x times x is positive 10x squared. To keep it going now in your box, you'd have to say 10x times negative 10 is negative 100x. But once again, when I come back over here, I don't have a linear term. I have nothing raised x to the first power. So what's going to cancel that out? A positive 100x. There, they would cancel each other out. So what did I multiply by to get a positive 100x? A positive 100. Positive 100 times negative 10 gets me my negative 1,000. A positive 100 times the negative 10 gets me my negative 1,000. And there I have in green my difference of a perfect cubed factorization. It's x minus 10 binomial times the trinomial x squared plus 10x plus 100. Now you're like, how the heck am I going to memorize that? Well, it's really very easy. And once again, this is Algebra 2. We're upping it. If you can't memorize this, I don't know what to tell you. This is what you have to memorize. Or if you're like, I can't memorize, this is what you understand. You understand that a perfect cube sum or difference factors down always into a binomial times a trinomial. How do I get that first binomial? I simply take the cube root of each term. So if that's a little something you have to add to these notes that you should be taking right now, you shouldn't be passively watching. You should be stopping the video, going, oh, I get that now. You should be writing yourself a little note saying something to this effect. I get this factor by cube rooting each term of the perfect cube. Okay. Cube root of x cubed, x, cube root of negative 1,000, negative 10. And then you know it's a trinomial and it has to multiply. I mean, that's the understanding part, that this binomial times a trinomial better get you my original. So I just kind of do it like this. I do, okay, well, it's a trinomial, so there are 3 spots right here. And this is why I hate the word FOIL, because FOIL doesn't work here, but double distribution does. So you have to say to yourself, x times what gets me x cubed, x squared. All right, and negative 10 times what gets me negative 1,000, positive 100. So if you see right here, it's saying a squared. And a is its first term right here, right? X squared. Negative 10 squared would be 100 squared. Now, I don't memorize that. I simply memorize that it's a binomial times a trinomial, then I figure it out myself. And notice that's it. This middle term's got to cancel out. So how am I going to get that to cancel out? Well, I'm going to multiply these things together, negative 10 times x, and it's going to be positive 10x, because that's the only way I'm going to get a negative 10x to cancel out is by with a positive 10x. So one of the things with perfect cubes factoring is that you're only allowed one negative sign. If I notice here, a plus b, there's one negative sign. And if I notice with a difference, there's one negative sign. Everybody else is positive. So once again, that's one of the things I just memorized. And here the negative sign showed up because when you take the cube root of negative 1,000, you get a negative answer. Therefore, everybody else has to be positive. So yeah, guys, this is going to take practice. And you need to just memorize that. All right, so just to show you how I do it, and again, it's memorization. I look at this and I realize that it is a difference of perfect cubes. So I come over here and this is what my result should look like. So I set myself up. Binomial times a trinomial. That's what I would get when I go to factor this difference of perfect cubes. So I remember I start off the same way. I cube root each term. Okay, x cubed is x. Cube root of negative 27 is negative 3. Ding, 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 ding. Oh, there's what I said. I'm only allowed one negative sign when I factor a difference of perfect cubes or a sum of perfect cubes. So therefore, my trinomial that goes over here are all plus signs in the middle. Well, x times, well, this has to be x squared. It's the only way I'm going to get x cubed. And negative 3 times 9 is the only way I'm going to get negative 27. And then my middle number right here, I just multiply those two together. See, it makes a smiley face. And I get 3x, and I'm done. Wham, bam. X cubed plus 64. Once again, I realize that that is an addition, a sum of two perfect cubes. It is the same thing. It is a binomial times a trinomial. How do I start off? Cube root of each term. Cube root of x cubed is x. Cube root of a positive 64 is plus 4. Now I know this is a trinomial. I have to fill it in with 3 terms, but I notice I haven't used my subtraction sign yet. I'm allowed one subtraction sign when factoring a sum of cubes or a difference of cubes. So I'm going to go throw my subtraction sign in. And, well, x times x squared is the only way I'm going to get x cubed. 4 times 16 is the only way I'm going to get 64. Make my smiley face, 4x. Done. And my last one, x cubed minus a cubed. Well, that's still a difference of two perfect cubes. Hey now, difference of two perfect cubes is a binomial times a trinomial. Cube root each one. X cubed, cube rooted is x, minus a cubed, cube rooted is minus a. Woof! Now I need a trinomial, and I went woof, because I have my negative sign. I'm only allowed one. You guys must be pluses. X times x squared is how I get x cubed. Negative a times positive a squared is how I get a cubed. Make your smiley face, ax. Done. So if you can memorize, heck, most of you can sing all the words to Hamilton, you can simply do this.